Roll for main engine start, 7, 6.
From space-age technology to baby powder, and from water filtration systems to precious metals and geothermal electric power generation facilities. This vast desert land encompasses some 200,000 square miles, which includes the states of California, Oregon, Nevada, and Utah, and provides an immense variety of resources to mankind. We will take a look at how to locate, unearth, and utilize these resources as we begin our journey into the fascinating discovery of the Great Basin and what lies beneath. The Great Basin, with its majestic mountains, flat desolate valleys, and beautiful sunsets, was created in ancient times from several massive lakes that through time and geological changes has left us valuable resources and remnants of their past. The Great Basin is an endorheic basin with no outlet for water to flow. Due to the nature of this closed basin and high solar evaporation, salts and minerals are highly concentrated. These salts and minerals sometimes provide the basin with what is called salt flats. All rain, snow, or any other precipitation that falls into the basin can only leave through seepage or evaporation. These types of basin are usually found in the hot, high, dry desert.
Well, when you can talk about desert, it generally means a low rainfall area. Therefore, this limits the normal cropping that we would see in other areas of the country.
Today, the remnants of these mammoth bodies of water lie in smaller lakes that have contributed extensively to the economy by way of helping and supporting industries within the Great Basin region. Some industries that are located within these regions are of the type that the product that they manufacture or engineer is very hazardous and kept reasonably out of view from the general public's eye.
There are people that live out here. There's ranching and agriculture. There's mining. There's oil down there in the ground.
The first step in locating most of the minerals that lie beneath in the Great Basin is the process of exploration.
As part of defining the resource and where you need to mine and the quality of the material that you mine, you certainly need to have geologists help define the material that you're going to mine.
A team of geologists ranging from engineering to geophysics engage in performing and supervising geologic and geophysical field survey work, which involves various types of analysis, including rock cores, soil and aggregate samples, data interpretation, and the preparation of geologic reports of findings. With most of the data compiled by our geologists, we will begin by informing the drilling contractor of the location, depths, and samples that we want taken. Sounds easy. So let's go take a look at a drilling rig. Here we find a small drilling rig working in the southwestern region of the Great Basin near Unionville, Nevada. There are many parts to a drilling rig, as we see here, starting with the spinner assembly that spins the drill shaft, the collar that connects the joints together, the pipe that varies in length and accommodates the drilling fluid, the weight that adds pressure to the bit, and the bit itself that grinds into the earth with the aid of the liquefied drilling medium. Drilling mud, also called drilling fluid, is a medium used in the operations to drill boreholes into the earth. Water-based drilling mud consists of bentonite clay with additives such as barium sulfate, calcium carbonate, and hematite. Various thickeners are used to influence the viscosity of the mud. The mud is used to cool and clean the drill bit and to carry the material to the surface for collection. This is done by shooting high-pressure mud through the feed hose down the drill pipe, which forces the fluid and the material engulfing the drill head to the surface, where it is discharged out through the separator and into the shale shaker. Shale shakers come in a variety of sizes, shapes, and forms. Most have 2 chambers, both of which are circulating and designed to take a specified size of the sample material and set it aside for collection. Here, at the bottom of the chamber, is where the samples are being pulled from. Selected quantities of the core material are gathered and collected in 5-gallon buckets. Smaller samples are then taken and sent to laboratories where it is analyzed for the specific materials that they are mining for. Depending on the depth and type of soil, drilling will require sometimes days to weeks before before the job is done. Now we know a little about how to find our rich deposits. Let's see what resources lie beneath in the Great Basin. Our first resource we're going to take a look at is water, essential and necessary.
Water is limited amount, and therefore it's recycled.
Today, dams provide most of the storage needs, but droughts indicate it's never enough.
We have to be more efficient in the use of it. Well, first of all, for domestic purposes, water is the most needed nutrient for our human body. Where water flows, food grows. Particularly in agriculture, we're seeing multiple uses of the water before it either evaporates into the air or percolates into the ground. And then for the food that's being produced for it, if it's for generating income from the farmer's standpoint, they have to find out crops that will be most efficient in that use and have a marketable value to it.
Besides being a necessary need for agricultural use, water has many uses in the industrial desert world.